In this video, we're going to learn how to store the response to an HTTP request into a string when using the easy interface of the libcurl library in C. So this video is part of a playlist covering the libcurl library. You might want to watch the first video in the playlist first. So first we've included the curl library, and next we'll set up an HTTP request using the curl easy interface. So first we'll declare a curl handle variable. We'll have here curl star curl for that variable, and this is going to store the handle for our request. Then we'll create a curl code variable to store the return value of the curl easy perform function. Then we'll call curl easy init to begin the easy interface session. So we'll have curl is equal to curl easy init, and this is going to start the session. Now the function is going to return null if there's a problem. Otherwise, it's going to return the handle. So if curl is equal to null, that means there's been a problem. In that case, we'll output to standard error an error message. We'll have here fprintf, and we'll have stderr, and we'll have http request failed, followed by a new line, and we're going to return -1 as an error status. Next, we'll call the curl easy set opt function to set the URL where the request is going to be made. We'll have here curl, the handle, as the first argument, curl opt underscore URL as the second argument, and this is the option that we're setting, and we'll set it to https://www.google.com. So we'll make the request to google.com, and curl opt underscore URL is the one option that we have to set. Next, we'll call curl easy perform to actually carry out the request. So we'll have curl easy perform, and we'll pass it our handle curl, and the function is going to return a curl code value, which we'll store into our result variable, and we'll check it, because if result doesn't equal curl underscore OK, then something has gone wrong with the request. So if result doesn't equal curl underscore OK, we'll output an error message to standard error with fprintf stderr, and we'll have error %s \n to output the error string, and we'll call here curl easy str error. And this function, when it's passed the result return value, is actually going to give us back a string as a return value containing a description of the error that has taken place. So we'll output that. Then here we'll have return -1 to stop the program with an error status. Finally, we'll call curl easy cleanup and pass it the curl handle. So we'll have curl easy cleanup, and we'll pass it the curl handle. And that's the last step to making a request with the curl easy interface. Now by default, this curl easy perform function is going to output the response received when making this request to standard output, which is going to be the terminal by default. So we'll save this and then compile the program. So we'll have gcc-l curl -od and d.c. Then if we run the program, we'll get back here our response from google.com. Now typically, we would want to store this response somewhere so we can look at it later and maybe pull some information from the response. Let's do that. Let's store this response into a string. So there's another option we can use called curl opt write function. We'll call curl easy set opt again, and we'll pass it the curl handle as the first argument again, but this time for the second argument, we'll pass it curl opt and then underscore write function. So this option allows us to specify a function, and this function is a callback function, What that means is the function is going to be called by curl easyPerform. Curl easyPerform is going to call this function repeatedly. Each time it does, it's going to pass the function a pointer to a new chunk of the response string. We'll call this function write underscore chunk. And here we're not calling write chunk, we're passing a pointer to the function as an argument to curl easy set opt. So the write chunk function has to have a particular prototype. We'll declare the function above main. We'll have here size underscore t write chunk. And then for parameters, we'll have void star data, size underscore t size, size underscore t n mem b, and then void star user data. So this here is the prototype the write function has to follow. The function and parameter names don't matter, but the argument types and the return value type do matter. We'll then define this write chunk function. So down here, we'll paste the prototype and we'll supply a definition of the function. Now at first, what I'll do is define a simple version of the function that's not going to actually store the data received into a string. Instead, we'll output each chunk of data received so I can show you what I mean when I say the function is called for each chunk of data. We'll have here printf, and we'll output a couple new lines, and we'll have begin chunk, and then a couple more new lines. Then we'll have end chunk, again with new lines around it. Then the way this function works is each time it's called, data is going to be set to a pointer that points to the block of data that was received in this chunk. And nmemb is going to be the number of bytes in that block of data. What we'll do is make a loop to output each character in that block of data. We'll have here for and size underscore t I is equal to 0, I is less than n mem b, and I++. Then in the loop body, we'll cast this void pointer here data to be a pointer to a character so we can use it to output each character in this chunk. So we'll have car star data to cast it to be a pointer to a character. And we'll take this, and then if we apply at the index I, this is going to give us each character in the chunk. We'll output that character using printf. We'll have printf and then %c to output a character, and we'll output this ith character. Now one more thing. This function is actually required to return the number of bytes in the chunk, which as a practical matter is going to be the value of nmemb. So we'll return that here. If we don't do this, it's going to result in an error. So we're going to return nmemb. So we'll save this and try it out. We'll compile our program and run it. And notice now that we can see each chunk. So as I scroll up, we can see like end chunk, and then here's a chunk. And then we'll have begin chunk. And then here's another chunk. We have end chunk, and then here's some more string data. And then we have begin chunk, and so on. So now we can actually see how the function is called for each chunk of data. What we want to do is take each chunk and put it into a string. Now, because we don't know how large the string is going to be until we actually receive all of it, we're going to rely on the realloc dynamic memory allocation function to continually make a spot in memory on the heap larger, so that each time we can store a larger string as is necessary. So what we'll do now is include the stdlib.h library. We'll have here number sign include stdlib.h. And we'll also include the string.h library so we can use the memcopy function to help us build the response string. We'll also declare a new type of structure to help us store the response string, because we're going to keep track of the size of the response string that we built so far using another member of the struct. So we'll have here typedef struct, and we'll call this struct response. Then we'll have here char star string, and this member is going to point to the actual string on the heap where the response is stored. Then we'll have here size underscore t size. This is going to store the size of the response string. Then down here, we'll declare and initialize a response struct to store our response. So we'll declare a response struct called response. We'll initialize the string member, and we'll have it point to a 1 byte block of memory on the heap by calling malloc with 1 as an argument. So malloc is going to return a memory address for this 1 byte block of memory on the heap. And we're going to rely on the write chunk function using realloc to expand this block of memory on the heap as is needed. Then we'll set the size member to 0. We'll set size to something meaningful the first time the write chunk function is called and we actually receive the first chunk of the string. Next, we actually have to set another option. So with our write chunk function here, data is going to point to the chunk of the response string that was received. User data is going to point to whatever we want. We can set it using the curl opt underscore write data option. The idea is that we set it to point to some place in memory or some structure or whatever where we're going to store the response string. So up here, we'll do that. We'll have here curl easy set opt, and we'll pass it curl. And this time the option is curl opt underscore write data. And for this third argument, we're going to pass the memory address. So we'll have here end response. We're going to pass the memory address of our response struct here. Now the parameter has the type void pointer. So we'll use a typecast here to typecast the response memory address to the type void pointer. So this means each time the curl easy perform function calls the write chunk function, it's going to pass it the memory address of the response struct here as the fourth argument, and we can use that to store the response string. So down here, let's do that now. We'll delete this here. Then we'll declare a size underscore t type variable called real underscore size. So in the official libcurl documentation, they say that the size argument is going to be 1. But the idea here is this argument here, nmemb, is the number of elements received, the number of things received, and size would be the size of those things. That follows a convention used in other C functions. So technically, to get the official real size, we should multiply size by nmemb, and we should return this. So here we should return real size. Now, as a practical matter, they tell us in the documentation that size is always going to be 1. So this probably doesn't matter too much in practice, but we'll do it because they do it in the official libcurl documentation. And this way, if somehow this ever changes, our code can handle that. So next, what we'll do is typecast user data to be a pointer to a response struct. So we'll have here response star and then user data, because even though it has the type void pointer, we know that really it's a pointer to a response struct. We'll store this pointer into a variable called response. So we'll have response star response to store that pointer into a variable called response. Next, we'll use realloc to allocate more space on the heap for this chunk that was just received. So we'll have here char star pointer to store the pointer that realloc is going to return. We'll call realloc, and we'll pass it response string. So that's going to be the memory address of our existing block of memory on the heap. We'll also pass it response size plus real size plus 1. So what we're doing here is allocating space for this many bytes on the heap, where response size is the size of the existing block of memory, real size is the size of the chunk received, and plus 1 is to account for the null terminator. Then what we'll do is check to make sure pointer is not null, because if pointer is null, we have a problem. That means realloc couldn't allocate space for this block of memory. So if pointer is equal to null, that means there was a problem with realloc. And in that case, we're going to return 0. So the libcurl library expects the write chunk function to return the number of bytes that were received in the chunk, which is going to be real size in our case. If it doesn't return that, that's a signal to the library that the function failed. In that case, it's going to abort the transfer. We could also return this special value they give us to abort the transfer. So we could also return this special value curl underscore write func error, and this will also abort the transfer. Now, if realloc succeeded, pointer is going to be a pointer to a block of memory on the heap that's large enough to store the new response string length, which includes the length of this new chunk that was received. So what we'll do is set response string equal to that memory address. So response string is going to point to our new larger block of memory on the heap. Next, we'll use memcopy to append this new portion of the response string onto the existing string that we've received. So we'll have here memcopy, and we'll pass it and response arrow string and response and then arrow size. So altogether, this is going to give us the memory address of the last character in the response string that we've stored so far, which is going to be the null terminator character, except for the first time write chunk is called when there is no actual string stored in memory yet. So this is going to be our destination memory address, where we're going to begin copying this new portion of the string. Data is going to be our source memory address, where the new portion of the string is stored, and we want to copy real size number of bytes. So we'll have that as the third argument. Then we'll update the size member of the response struct. We'll have response, and we'll update the size member. We'll increase it by real size, which is the number of bytes in this chunk. Finally, we'll put the null terminator onto the end of this new string. So we'll have here response string at the index response arrow size is equal to the null terminator. Or we could just assign 0 here, and that's also going to work. So next, up here, we'll output the string that we've created by appending all these chunks, the string that response's string member is pointing to. So after the function curl easy perform is called, we'll output here with printf %s to output a string followed by a new line, and we'll have response.string to output that string. Then we'll also free the memory that is used to store this string. So we'll have free and response.string to free the memory. So now we'll save our program and try it out. We'll recompile it and run it. And we're getting the response string as output again, but this time it's because we're outputting a string that we've stored in memory. And the whole trick to this code here is write chunk is repeatedly called, and when it is, we keep using realloc to increase the size of the block of memory where we're storing the string, and we keep using memcopy to append the new string chunk to the existing string. So this is how we can store the response string we receive when using the libcurl library in C to send an HTTP request. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.